Okay. So next morning, everyone. Tonight's topic is glutathione, role of glutathione and insulin sensitivity. As Joel said, we are commemorating the World Diabetes Day sometime this month, and this topic is relevant to diabetes. Okay, so let us get to know insulin better. So insulin is a peptide hormone secreted by the beta cells of the pancreas. When you say that it is a peptide hormone, then you know it is made of amino acids. So in fact, it is made of 51 amino acids arranged in two chains. Afterwards, I will show the molecule structure. So two chains, A chain of 21 amino acids and B chain of 30 amino acids. Among its functions, and its most famous and most important function, is maintaining normal blood glucose levels by facilitating the cellular glucose uptake. So in doing so, it regulates carbohydrate metabolism, but also lipid and protein metabolism, and it promotes cell division and cell growth. As an important point to note is that while it facilitates the glucose uptake to all the cells, especially the muscle and the liver cells, but the glucose can go in without its action. The glucose can enter the beta cells, which produces the insulin. This is important to know, because if it has to require insulin to go into the cell that manufactures insulin, then we'll be in trouble when we don't have enough insulin. What happened now? Okay. Okay, so this is the insulin structure. So the blue chain is the A chain, and the red is the B chain. And you will notice that there are the double sulfur bond, the disulfide bonds in between the two chains, and also in between the two halves of the two parts of the A chain. And the sulfur, the disulfide bond, is between the cysteine. Okay, you remember the molecular structure of glutathione. In the center, the cysteine, and it has the sulfur hydride group, the sulfur and the hydrogen. And then the oxidized form of glutathione is GSSG. So you can see here it is CSSC, cysteine, sulfur, sulfur, cysteine. So whenever there's cysteine, then there will be a disulfide bond to another cysteine. So you can see all the cysteine are joined to another cysteine with a disulfide bond. And this gives it the 3D structure. The bonding will force the chains to go into a certain 3D structure. And on the left is a simplification of this chain and how it would look like in 3D. About the history, it was first isolated and purified in 1921. Previously, it was only known that the extracts from the pancreas reduces sugar, glucose, until it was isolated and purified in 1921. The first human experiments followed immediately the following year. Sorry. And the first commercial preparation, the pig or porcine insulin, in 1923. And the same year, the Nobel Prize was awarded to the discoverer, Frederick Banting, and Professor MacLeod, who supervised the studies. But it took another 30 years, almost 30 years, for the amino acid sequence to be identified, and another 20 years for the insulin receptor on the cells to be identified. Okay, so how does insulin work? So as far as for the glucose metabolism is concerned, the insulin locks onto the insulin receptor, right, on the cells that require glucose. And then once the insulin is locked onto the insulin receptor, then there are internal signals that are sent to the glucose channel. So the cells that require glucose will have an insulin receptor and a glucose channel. But the glucose channel is closed. Can be only opened when the signal from the insulin arrives. That is when the insulin is locked onto the insulin receptor. Then internally there are signals that are sent to the glucose channel for it to open. And only then can the glucose come in. So this is quite complicated. It is not just a matter of there is glucose and the cell requires glucose. It will take in the glucose. The cells cannot take in glucose without the unlocking of the insulin receptor, right? As mentioned earlier on, except that the beta cells of the pancreas, which produces the insulin, that in those cells, the glucose can go into the channel without needing the instructions from the insulin receptor. Okay, so this is what most people are aware of about the function of insulin onto the cells. But we must also be reminded that there are many other important functions of insulin, which I will mention later on. Okay, so understanding the role of the insulin receptor and the glucose channel, now we can go into more detail. So the glucose in the blood is therefore actually good for the cell. The cells need glucose to work, to make energy. We always say glucose is bad, glucose is bad. Actually, the glucose is good for the cells. So once the insulin receptor receives the instructions from the insulin, then the glucose channel is then opened, then the glucose comes in, then the glucose is used for energy, is used for storage, and then also excess glucose is stored as glycogen, all right? And also through some chemical steps, then is converted into fatty acids, then stored as fats. Okay. Okay, so you see the most important function is to let in glucose for energy production, and then excess glucose, glucose storage, and then fat storage. Okay, one thing not mentioned here, also for protein synthesis can also be done. So the signal or the instruction from insulin is required for the cell to take in glucose. The cell insulin receptor must be healthy and work efficiently, right? So we'll be focusing a lot on the receptor. Glucose is required for energy production, glycogen storage, and fat synthesis and storage. So the cells need glucose. Okay, so now let's talk about insulin sensitivity and insulin resistance. What do we mean by insulin sensitivity? This refers to the ability to elicit biological response to insulin, right? So meaning if the cell is sensitive to insulin, then it can it is able to have the biological responses to the instructions of insulin. And what do we mean by insulin resistance? This is where a normal or elevated insulin level produces a reduced or attenuated biological response, right, instead of the normal healthy response. The biological response to insulin are those mentioned earlier on, right? opening up the glucose channel, and then enabling the energy production, and then enabling the glycogen storage, and then the fat storage, and also the protein metabolism. Plus another big function, the cell division part will also is another response to insulin also. But usually this response is just tested and measured by the ability to regulate glucose uptake and metabolism. So when we talk about insulin sensitivity, it is the reverse of insulin resistance. In other words, high sensitivity equals low resistance, or high resistance equals low sensitivity. But most of the time, you will be referring or mentioning insulin resistance instead of insulin sensitivity, because the problem is resistance or low sensitivity. For example, type 2 diabetes is a disease of insulin resistance or very low sensitivity. So you can see there is insulin and there is glucose, right? And the insulin receptors on the cells need the insulin to lock onto receptors, and then instructions are sent to the glucose channel called GLUT4, and that will open up, and then the glucose transporters will bring in the glucose. So when there is insulin resistance, meaning there is defect at the level of the insulin receptors, that even though insulin locks in, the signal is weak or poor, so there is a defect in the signaling to the glucose channel. Because of that, there is reduced glucose uptake, right? So the problem is with the receptors. The resistance, we're talking about resistance, it is the problem with the insulin receptors. It's almost as if they are resisting the instructions of insulin. So having understood that, certainly then we can understand that insulin resistance increases the risk of hyperglycemia and type 2 diabetes, and then also of overweight and obesity, hypertriglyceridemia, that means high triglycerides, hypertension, and surprisingly developing major depression disorder. And I also read also not just the depression, also psychosis. So what are the risk factors that can lead to insulin resistance? The sedentary or inactive lifestyle, having low levels of good cholesterol, or having high levels of triglyceride. You start with high level, already you are predisposed, and then insulin resistance will make this worse. You have family history of diabetes, you have high blood pressure, or you already have symptoms of pre-diabetes, that means hyperglycemia. Or for a lady who have a history of gestational diabetes, right? That is, you have diabetes during pregnancy. Or you gave birth to a baby more than 9 pounds, that is 4.54 kilo plus. And also a history of having a stroke. These are some known risk factors for insulin resistance. Okay. And these are other factors is not mentioned in the list. Of course, aging is one factor, and then hormonal problems, high carbohydrate, a high sugar diet, oxidative stress, toxins, and inflammation. All this will lead to insulin resistance. And then insulin resistance itself causes many other problems, including diabetes, dyslipidemia, hyperinsulinemia. That means insulin resistance will cause you to have high levels of insulin because your body will try to normalize the signal. If the normal amount of insulin does not give normal level of signal, then the body will try to improve that situation by producing more insulin. Okay, so the next is, we know that insulin resistance, our main issue is diabetes, but we need to distinguish first the difference between type 1 diabetes and type 2 diabetes. In type 1 diabetes, there is high sugar levels in the blood due to insufficient insulin production by the pancreas. Type 1 diabetes is an autoimmune disease affecting the beta cells, causing beta cell dysfunction and reduced production of insulin. Okay, so the damaged pancreas, damaged beta cells, decreased insulin in the blood vessels, and therefore the cells, especially the muscles, cannot take in glucose as much as it needs, and the glucose remains in the blood, so you have hyperglycemia. Okay, and because of that, the body is forced, right, to break down fat and glycogen and protein to try to provide the calories and the energy sources. So you may end up with what's called ketoacidosis. If not treated, type 1 diabetes, you end up with ketoacidosis, right? Because the body has to break down all the fat to use as the resource material to make energy. Okay. Whereas type 2 diabetes is you have high sugar or hyperglycemia due to the failure of the cells to respond to insulin. That is insulin resistant. So in type 2 diabetes, you have sufficient, in fact, even maybe a higher level of insulin if the body is trying to cope. Okay, but in spite of that, because of the insulin resistance, the muscle is still unable to take in normal amounts of glucose, so you have high levels of glucose in the blood. So type 2 diabetes, you have high blood sugar due to insulin resistance. Okay. So now we look into the other functions of insulin. So you can see at the receptor level, the insulin binds in, and that triggers signals to two major pathways. One is the metabolic effects, right? That increases glucose uptake, increases glycogen synthesis, and then protein synthesis, and then prevents the breakdown of fat, and also increases the storage of fat. The other major pathway is the mitogenic effect in the nucleus. That is, it works on the chromosomes and the genes, and is important in giving signals for the cells to multiply, to reproduce, and also very important for cell survival. Okay, so insulin is not just about glucose. It's also about fat and protein and gene expression, and about cell survival and cell reproduction, cell multiplication. Okay. Now, let's go to the stages in the evolution of type 2 diabetes. So you start with a healthy person who has low glucose and low insulin. The healthy person should have low insulin, which means the system is very efficient, right? You just need low levels of insulin to maintain low levels of glucose. And then if this person does not take care of his or her health and starts developing insulin resistance, right? That means the insulin receptors and the cells, especially the muscles, start having problems, then the body will start raising the insulin level to try to keep the glucose low. So if you do the blood test only, you will just see the glucose is normal. If you don't do the insulin level, you will not know that this person has insulin resistance because you only see that the glucose level is normal. But if you check both the glucose and the level of insulin, then you will see that the insulin level is raised, then you know there is insulin resistance. Then if nothing is done, then this person progresses to the next stage, which is pre-diabetes, whereby in spite of even higher level of insulin, the glucose level starts to rise, right? So because the signal received is not enough, so the cells cannot take in the sugar, then the sugar level is raised, but it's only slightly raised, not high enough to be classified as diabetes, but so it is classified as pre-diabetes. And then if the condition is allowed to progress further, then you have overt diabetes type 2, where in spite of high levels of insulin, then the glucose level is high, right? High enough to be classified as diabetes. And then, especially if poorly controlled over many years, chronic, moderate, and severe diabetes will progress to a stage where even the pancreas become damaged, right? You know, diabetes will cause damage to many organs, head to toe. Over many years, even the pancreas become damaged. And when the beta cells of the pancreas are damaged, then insulin production is affected. So now you have a situation where the type 2 diabetic person has a condition almost like type 1 diabetes, because the pancreas is now damaged and insulin production becomes low. But the difference is, in the type 1 diabetic person, the pancreas is damaged by an autoimmune problem. But the cells do not have insulin resistance. So when you give insulin, the cells respond to insulin very well. But in this person with type 2 diabetes, a chronic over many years, then this low insulin production that is mimicking type 1 diabetic is happening on top of severe type 2. That means not only now the production of insulin is affected, but the cells have this problem of insulin resistance. Whatever insulin is available does not give the right signals to these cells. Okay, so in this situation, the patient will need insulin injections, but because of the insulin resistance, this person will need high doses of insulin. So by this stage of the severe type 2 diabetes, then this person will need insulin just like the type 1, but will be needing high doses because of the insulin resistance. Okay, so for type 2 diabetes, insulin resistance is actually the primary problem. The high blood sugar, the hyperglycemia, is not the primary problem, but the result of insulin resistance. Other problems of diabetes that are forgotten are that the cells are starving, and that insulin has other important functions on the cells. All right, take note that in the diabetic person, either type 1 or type 2, although the sugar level in the blood is high, there's hyperglycemia, but their cells are starving because the cells do not get the glucose. Okay, must remember that. Now, if insulin resistance can be reversed, example, by improving insulin sensitivity, then hyperglycemia and other problems will be reversed automatically because now the cells can take in the glucose, so the glucose level will go down. However, more than 95% of the anti-diabetic drugs aim to reduce glucose by other means, not by reversing the real problem, which is insulin resistance. Insulin injections for type 2 diabetes solve the problem temporarily, but allows the disease to get worse. Hence, higher doses are required over time until the cells fail to respond to insulin completely, and by that time you're dead. Okay, if your cells cannot respond to insulin anymore, you are dead. And many end up dying when this crisis happens. Okay, what about the forgotten problems of diabetes? Right, because everyone only worries about the glycemia, forgetting that insulin has other important functions. Okay, so the starting problem is here, insulin resistance. But as mentioned earlier on, right, because insulin has other functions, it's not only the glucose metabolism is affected, fat metabolism is affected, protein metabolism is affected, but also the other major functions of insulin, which influences cell growth, cell proliferation, cell survival, right, and gene expression. Okay, so the problem there will affect this pathway, that pathway, that pathway will affect this function, that pathway, and this function. So there are many, many other functions, important functions of the cell, but cell growth, survival, proliferation, gene expression are very, very important. So don't forget, it's not just about glucose metabolism. You have problems with insulin resistance, you have many, many other problems. In fact, there are more problems due to poor insulin signaling. That means insulin resistance and cell starvation than due to the hyperglycemia. Hyperglycemia gives some problems, but it is actually only a result, a consequence of the poor insulin signaling or insulin resistance. Okay. So reduce insulin signaling due to insulin resistance, then will cause the glucose intake to be reduced, and plus also reduce in all the other function depending on insulin signaling. But at the same time, all right, we do not ignore that. Then the hyperglycemia also does give additional problem, contribute additional problems. That is oxidative stress, inflammation, susceptibility to infections, all right, increased blood viscosity, etc., etc. Right? So yes, hyperglycemia does add more problems, but it's only in addition to the other problems that happens before hyperglycemia happens. That is the starvation of the cells and the dysfunction of the cells due to the lack of insulin signaling. Okay, so from the hyperglycemia, then you have oxidative stress, inflammation. Oxidative stress and inflammation contribute to damage and dysfunction of insulin receptors on cell membranes, causing insulin resistance and later diabetes. So it adds to the vicious cycle. Okay, you start with whatever poor lifestyle leading to oxidative stress and inflammation. And when you have insulin resistance, you have hyperglycemia, that this will cause more oxidative stress and more inflammation. Okay, so the hyperglycemia of diabetes induces formation of more free radicals and inflammatory byproducts, thus exacerbating the problem. This worsens the insulin resistance and diabetes. Cell starvation and the high levels of free radicals and inflammation are responsible for many of the complications of diabetes by damaging many cellular components and many organs. In fact, studies have shown that the oxidative damage is present before the development of type 2 diabetic complications. Okay, so this is the vicious cycle. You start with the risk factors, your genes, your poor lifestyle, poor diet, obesity, then oxidative stress, inflammation, and toxins, etc., from your type of unhealthy lifestyle and diet. Okay, and this leads to insulin resistance, and if it worsen and allowed to develop to diabetes, then on one side, then you have hyperglycemia. Okay, on the other side, you have organ damage from the oxidative stress, inflammation that is causing the insulin resistance and diabetes, and also there is results from the insulin resistance and diabetes. Okay, the hypoglycemia also worsens organ damage because it worsens oxidative stress and inflammation and other problems. So this is a typical story of the poorly damaged diabetic patient, is that it goes around in circle, is a vicious cycle of progressive worsening of diabetes and organ damage and complication. Unfortunately, much of the therapies given by the doctors, right, does not concentrate in reversing insulin resistance, but just concentrate in reversing hyperglycemia directly. Okay, as a result, over many years, then the diabetic person end up with complications from head to toe, right? From stroke to dementia, to eye problems, heart disease, kidney disease, pancreas dysfunction, erectile dysfunction, neuropathies, arterial disease, and then in the end, cancers, and they end up with amputations of the foot or lower leg or even above knee, and then die. Okay, so what can glutathione do? Many studies have shown that glutathione improves insulin sensitivity, all right, which then help improve diabetes control and possibly even reverse the disease. Secondly, glutathione, apart from improving insulin sensitivity, also protects these organs from damage. It slows down, reduces, or possibly even reverse the damage. So high level of glutathione in healthy people may help prevent or delay the onset of diabetes by making sure that the insulin receptors are in perfect condition and they work well. And when insulin locks in, then the insulin signals are strong and all the functions of insulin on the cell then will manifest in a healthy way. Glutathione can help prevent or slow down or even reverse the damage to the cellular insulin receptors that cause insulin resistance. The receptor damage is caused by free radicals, toxins, chemicals, and other factors, many of which can be neutralized by glutathione. Diabetic hyperglycemia causes an overload of free radicals and inflammatory agents that worsen the insulin resistance and diabetes, and also cause damage to many organs. And we know that glutathione can help prevent, slow down, or even reverse these complications. And we have many testimonies as well. I remember this chart earlier on, I showed that that the oxidative damage is present even before the complications appear, and this oxidative damage are caused by a whole range of unstable molecules, reactive oxygen species, reactive nitrogen species. Okay, what's relevant to us is that glutathione is found to be able to protect or reverse the damage caused through almost all the different types of harmful molecules. These are some references of studies that show that glutathione improves insulin sensitivity. Okay, finally, just to share with you, glutathione not only improves insulin sensitivity or reduces insulin resistance. In fact, it also plays a role in the beta cells in regulating the release of insulin, right, to the blood. All right, the insulin release is called through a process called exocytosis, right? Because the insulin actually are produced and stored in small pockets or small let's say pockets. These insulin granules, then these are then released by releasing them out from the pockets to the external part of the cells. So there are many factors involved, but glutathione is one of those important factors that regulate this release. So you can see glutathione plays many roles, like in many other systems also. When you study, you find that glutathione plays many roles in that system. So in the insulin system, it plays a role in the release of insulin. It plays a role in making sure that the insulin receptors are healthy. So that is why glutathione is very important part of the insulin system. So thank you very much.